something that can also help protect biodiversity is artificial intelligence, and that's the topic of our next session, which is called Making Offshore Renewables Smarter. To talk about that, I'd like to ask Karine, Heerah, Olivier Berger, and Bruno Guerin to join me on stage. Bonjour. Okay, do you want to grab the microphone? Yeah. Thank you so much for being here a bit early. So, good afternoon. Karine, Heerah, you're a scientific researcher at Research Institute France Énergie Marine, and your organization, I understand, is working on 2 research projects regarding birds. Can you tell us a bit more about that?
Yeah, indeed.
Let's hold it very closely to you. Yeah.
Indeed, we have 2 research projects in which we use AI tools to study the interactions between birds and offshore wind farms. So we use AI to study their movements at different scales. So the Semaphore project, using AI tools to detect and forecast bird migrations from weather radar. And so we can forecast migration up to 2 days in advance, which is super useful to provide migration alerts and plan efficiently, for instance, turbine shutdowns. And then we have the Drakkar Mermaid project, in which we use videos and AI tools to detect and track bird movements at really fine scale.
Can you share first results with us of these projects? I know that they're research projects that are ongoing.
Yeah, so first of all, Drakkar Mermaid, because there are less results as the project started 9 months ago. But in Drakkar Mermaid, we deploy several instruments on a Met mast in Fécamp. And those instruments have been deployed. We already have first algorithms that are really successful to detect birds. But we need more labeled data to be able to transfer those algorithms to other sites. And Semaphore started 2 years ago and will finish next year. And so at the end of the project, in collaboration with Météo France, we will release a beta web platform on which user will be able to see in real time bird migrations and our forecasts.
I understand most of the data for now is on onshore projects, right? Not really related that much to offshore wind energy projects.
Yeah, it's true. Like in Semaphore, we see that the forecasting are really good at continental scale, but they can lack of spatial resolution, especially at sea. So we need more data at sea, always more. So we see 2 complementary approaches. So we could use, for instance, radar that could be deployed in offshore wind farm to improve the resolution and the forecasting of bird migration at sea. But the thing is, with radar, you cannot go down to the species level, so we also need more initiatives like Drakkar Mermaid to instrument more platform at sea so that we can have information on the birds that use wind farm and how they behave when they reach the farm.
This session is obviously on AI. I think we're seeing the Drakkar Mermaid.
Yeah, so there's that's a video on which you can see the 2 squares of the detection from the model, but also the detection from manual annotation.
So you can see that AI really is being used to identify the birds, right?
Yeah, exactly.
How does it, I mean, oops. How much is AI used in another way for these projects, or how important is it?
Yeah, so as a biologist, we know that to extract relevant ecological processes, we need long-term data sets, and for a really high fine-scale resolution. But with AI, it's a real breakthrough to actually analyze huge and complex data sets, such as the one from radar and video data. So we can use classical AI models for detection tasks, like the one on the left. But we can also use cutting-edge AI models to forecast and model who model and forecast complex ecological processes.
Okay, well, great. Thank you so much, Karine.
Thank you.
Bruno Guerin, your company uses AI in a slightly different way. You are, hello.
Hello. Nice to meet you.
Nice to meet you too. You are sales manager at Austria-based CAI, which provides optronic systems. So what's that exactly?
So yes, I'd like to start first of all by the fact that CAI has started a few years ago by the encounter between Guerin, which was the IMOCA class director, and Raphael Biancal, who was coming from Austria, from the automotive industry, and he wanted to transfer the technology from automotive to the maritime navigation. So the problem with the IMOCA class was to finish the races between when they were racing around the world. They wanted to avoid containers, they wanted to avoid whales, they wanted to avoid small boats. So they come up with the idea to use artificial intelligence and optronics. So based on thermal cameras, low-light cameras, machine visions, and artificial intelligence. So I don't know if you have some video to show quickly how it works, but I can explain by
Do we have a video?
quickly how it works.
Ah, there we go.
Very good. So basically we are scanning what with the optic electronics devices, we are scanning what is around the vessel or on the region of interest. And with machine vision, we are detecting any floating objects. And with the artificial intelligence, we'll be able to make identification of what has been detected. And we're going to provide some alerts to the skippers or to the person to observe a region of interest. So we make detection, classification, and risk assessment by the distance between the intruders or the whale or whatever you have floating on the sea and the region of interest.
It's for security, but also safety. So if someone goes overboard, you'd be able to identify that.
Exactly. So it can be used for safety, security, to get some situation awareness about what is going on during days and night, because thermal cameras are working also during the days. And that's it, how it works. And the system itself, it is thermal cameras and low-light cameras, and we have a panel tilt to make automatic 360 degrees rotation, and it is scanning what you have around the boats.
And I understand your system is already deployed at certain offshore wind energy farms.
Exactly. So as of now, it is used by CTVs in order to be able to avoid any floating objects, as I said, any whales. It is also used for coastal monitoring in order to check what will be the intruders. And we have also some of our systems also deployed for search and rescues, in order to be able to provide some assistance and support on people at risk.
Are you going to expand that way to use your system? Can it be used? Will it be used more widely at offshore renewables projects, do you think?
So yes. So first of all, the first market for us was not the wind farms, but now it's getting more and more important. People are getting concerned about whales' activities, as they are also getting also quite sensitive about any collisions. So this system is very useful for that.
Right, well, great. Thank you so much.
Thank you.
Olivier Berger, you're general manager, I'm sorry, at Makila AI, based in Paris and Montreal. And your company's technology is being deployed in the areas of manufacturing and predictive maintenance, right? Tell us a bit more about how it works, what you're proposing, what you're offering.
Hello, everyone. What is fascinating when I share a panel with other AI specialists is each time I learn something, I feel like it's an infinite world of AI being capable to support and help industrial people. and any type of operation. So Makila AI is a 8 years now company based in Montreal and in Paris. We have so we don't detect birds or floating potential collisions objects on the ocean, but we take all your data. I like your sentence before. You were saying we need more data. We believe in Makila that we are all sitting on a gold mine. The gold mine is the set of data unexplored in your company. So for manufacturing and predictive maintenance, you are right, we are working on these two fields because we can identify patterns of efficient, from an energetic standpoint or operational standpoint, patterns of operations, and what is going wrong or what is going to lead to a failure. So instead of preventive maintenance, but predictive maintenance, we look at your data so that we can predict and see things that you have in your data. Each time an industrial company is giving me his data, each time I fear when I am back to this company that is telling me, Olivier, it was not worth having artificial intelligence to teach us what we already know. And each time we discover patterns on data, on manufacturing, on operations, on the marine sector where people didn't know, didn't expect a pattern to exist. So the good news is that thanks to AI, you can explore the gold mine that you are sitting on every day.
And you brought one slide. If maybe we could show the slide on the screen.
Yes, it's basically on the data collection, and I would like to thank my friends of ATS company who has invited us and who are exploring with us more and more opportunities on the manufacturing side. We are doing the data collection on the firm and solid data coming from all your ERP, all systems, sensors, and IoT that we are working on with ATS, but also the qualitative data, with technicians or people writing in natural language what they have seen on the field. And this data is very often not utilized enough. So with artificial intelligence, we can process the natural language so that we can combine the natural language of what the people have observed on the field and the hard data that your system, your IoT, your sensors have put in place. After that, we do the metadata and all the processing of the data so that we can, first of all, see the inconsistency between data and explore several projection and predictive situations based on your history of data and a variable that you can interact with the platform. So Makila, basically, AI is a platform of algorithm with machine learning that we give you. We can help you, but you can become autonomous and use this platform to utilize your data to predict better what is going to happen on your field.
And so far, I understand you're not active in the offshore renewable sector, but that could change at one point, could be useful for the sector, your technology, right?
Exactly. So we are working on the marine sector already, but not yet on the renewable energy sector. But it's very easy. Each time you have something that you cannot modelize completely, or things that you don't master, or phenomena that you don't master completely, AI is going probably to help you to better master your physical phenomena on your operations.
What about smart grids? I think I understand that's an area you're working on actually that could be useful for the offshore renewable sector.
Exactly, on the transmission distribution of electricity and the smart grids, it's the same. You have a lot of data, many are unexplored, and AI is helping you to see the patterns of what has been existing, and you can predict better by influencing also the algorithm in machine learning on what is going to happen so that you can optimize better your grid.
Great. Well, thank you so much. Thank you, Olivier Berger, Karine Heerah, and
thank you to all.
Bruno Guerin. Thank you. Thank you for participating, and thank you for listening.
Thank you.
Thank you.